Welcome to Justice Today, the official podcast of the Department of Justice's Office of Justice Programs, where we shine a light on cutting-edge research and practices and offer an in-depth look at what we're doing to meet the biggest public safety challenges of our time. Join us as we explore how funding, science, and technology help us achieve strong communities.
Welcome back to the show, everyone. My name is Josh Mondoro. I'm your host for today, and we're going to be talking about marijuana. There are lots of conversations that are being had about marijuana, whether it's good, whether it's bad, whether it should be legal or illegal. We're going to take a bit of a different angle and look more closely at what is still unknown in this field from a criminal justice standpoint. There are a lot of issues and questions that are still facing researchers who are working in this area, and we're going to try and come to an understanding of what those are today. Joining us is a returning guest to help us with this. She is a physical scientist with NIJ's Office of Investigative and Forensic Sciences. She holds a PhD in chemistry from the George Washington University, and we are so happy to have her back on the show. Welcome back, Dr. Frances Scott.
Thanks, Josh. Nice to be here.
All right, so this conversation we're going to kind of do it in two parts, so listeners stay tuned. But for part one, we're going to stick with drug chemistry. So there's kind of, from what you've told me, there are two halves to this conversation, so to speak. There's the drug chemistry aspect, and there is the toxicology aspect. So let's get some groundwork in here. Can you define for us what those things are and what we will be talking about today?
I can, because I have to define them every time we get new leadership in who may not be familiar with our kind of science. So drug chemistry is looking at the actual drug, the actual substance. So the plant or the vape oil or the edible, in the case of marijuana, those types of products. And so that's where you're looking at the actual components of the thing that you're going to take into your body. Toxicology is looking at the drug in your body. So there we're looking at some matrix from the body, some biological matrix. So oral fluid, urine, blood, etc.
So to someone like me who doesn't study and research this all the time, both of those sound very similar. Almost like you can't have one without the other, kind of. So is there a lot of overlap between those two, toxicology and drug chemistry?
It's a good question. There's a lot of overlap there, but they tend to be looking at different questions. And in the case of a crime lab, it tends to, you're looking at usually perhaps supporting different types of charges. So you really are looking at two very different kinds of samples going to two different kind of branches of chemistry.
Awesome. So with that said, let's start in with marijuana from the drug chemistry side. And actually, let's start here probably. What is marijuana? Let's define that up front. What are we talking about?
Right. Okay. So, and spoiler alert, we're going to be talking about marijuana and we're going to be talking about hemp. And what you need to know is both of those are the same plant. So let's bear in mind, I'm not a botanist, but you know that we can breed plants to have particular characteristics that we want, right? You can breed your sunflowers to be taller and your corn to be more robust. And so in the case of marijuana and hemp, those are both cannabis sativa plants, and one has been bred to have more pharmacologically active compounds, and the other is has some of the other cannabinoids that are not going to have the same kind of mental effects.
And which one is which? Just for our listeners who maybe aren't familiar, which one's which?
Right. So hemp is the one that it has been bred to not get you high, and whose fiber is extremely useful and sustainable. So that hemp is interesting from a farming point of view because it can take the place of some crops that are less sustainable.
Circling back quickly to the I don't know if you use, so correct me if I'm wrong, I don't know if you use the word psychoactive, but I tend to associate delta-9 THC with psychoactive stuff. Is that the compound you're talking about when is part of the difference in these definitions, like the presence or absence of that compound?
Yeah, so I kind of steered away from the compound, but yeah, so delta-9 THC is the most known psychoactive compound. And it is the one that is generally most associated with kind of the known getting high effects of marijuana. So yeah, that's the difference, is that hemp is going to have very low delta 9 THC and higher CBD, which is cannabidiol, and marijuana is going to have the reverse. It's especially going to have a higher THC content.
Okay, gotcha. With those definitions, right, there's a few years ago, a bill passed called the Farm Bill in 2018, right? Can you talk about what that bill was and like what its impact was on drug chemistry, maybe on these definitions and how that, yeah, because there's a lot there.
Yeah, so the kind of general definitions that I just gave, sort of are very qualitative, right? I said sort of high CBD, low THC is hemp, and high THC, low CBD is marijuana.
Right.
But how high and how low? And so what the Farm Bill did, like I said, hemp is interesting from an agricultural point of view, as an actual crop, and so the Farm Bill legalized growing hemp.
Okay.
For those purposes. And so it needed to define more specifically what that is. And so I'm going to read you the definition from the Farm Bill. And so it says hemp is the plant Cannabis sativa L and any part of that plant, including the seeds thereof and all derivatives, extracts, cannabinoids, isomers, acids, salts, and salts of isomers, whether growing or not. Hold on, we're not done yet. With a delta 9 tetrahydrocannabinol, that's THC, concentration of not more than 0.3% on a dry weight basis.
Okay. That was a lot.
Yeah, so that was a lot. And it's challenging from a drug chemistry point of view. So lots of laws and bills are written by politicians, and politicians,
Yeah.
Scientists tend to be underrepresented in politics, is what I'll say there. And so they do the best they can, but sometimes they use words that are not necessarily the types of words we would use, or that are where we all kind of understand what they mean.
Right.
So, for example, it talks about derivatives. So a derivative of that plant. So what does that mean from a scientific point of view? And so there's a lot of discussion right now, has been since the bill passed, around some of these definitions. Any part of that plant, including the cannabinoids with a delta 9 THC concentration. So cannabinoids are sort of all of these THC, CBD, CBN, CBG. There's lots and lots and lots. All of those components of the plant. Yeah. So are we talking about all of them? But then we're talking specifically about delta 9. Isomers is especially, that's a very specific scientific word. But yeah, so an isomer is basically, it's a compound that has the same weight and chemical formula, but it's put together differently. So you had the same building blocks of it. You have the same number of carbons and hydrogens and oxygens, but you've assembled them slightly differently. So that's an isomer.
So it creates a different compound.
So it's a totally different compound, and it may behave differently. But by saying the isomers of that plant, but then we're talking about delta 9 THC. And so this has really been very complicated for drug chemists. And then in addition, because it used to be, it's all marijuana, all the cannabis sativa plant that has a measurable THC that you can see that there's THC in, done and dusted, that's marijuana, right? And so that you could sign out a lab report saying this is marijuana. Now, because we have quantified this very specific amount of delta 9 THC on a dry weight basis, and it's a percentage, that gets complicated. And so drug chemists were faced with needing to quantify THC concentrations, which they've never had to do before, in order to be able to testify or sign a report that says this is marijuana, because we didn't have to make those distinctions before. And then, if you thought that was all complicated, but wait, there's more, right? So then we talk about derivatives and extracts. And so it's the plant, any part of that plant, including derivatives, extracts, etc. So now think about all the products that you see at CVS, at the gas station, that have a combination of letters on them, and they may say CBD, they may say delta 8 THC, they may say full spectrum cannabis oil, So now you've got all of these products. And what does that mean when you're trying to figure out what the Delta 9 THC concentration is on a dry weight basis of something that's a lotion or an oil?
Right.
Right.
Right. Yeah. Couple of questions came to my mind. One was, is there a difference, or maybe what is the difference between like a derivative and an extract? Is it, and like, yeah, and I guess you kind of alluded to like that's the question, but
And that is kind of the question. And so, how I might define that in a lab,
right.
like derivative is not necessarily a term we would use very often, unless we were back in calculus and doing those kinds of derivatives.
That's what I thought of, honestly. So
Right.
I wanted to get some clarification.
So I think, I can sort of speculate from the way that it's written. Extraction, we kind of understand that process a little bit better, and
Yeah.
probably understand what that means. There is that you're removing some compound out, compound or compounds, some components of that plant. That's going to be an extract. And so I think a derivative could be similar. It's if you've done something to the plant or the components of the plant. But again, how far does that go? Like, at what point is it no longer a derivative? At what point is it like a whole new thing?
Something new.
Right.
Right. Right. That sounds very, very messy.
Yes, it is.
Yeah, absolutely.
And also, by the way, 0.3% is very, very low. So I'll talk to you a little bit later about some research that we've had in this area, but
Yeah.
and an article that we published. But it's low, and it's hard, even if someone is trying to. It's very easy to have. Let's put it this way: there's very easy to have a plant that because of growing seasons and whatever might be just a tiny bit over that 0.3%, and so that could be someone who now has an illicit plant that was not their intention.
Right. That's not really their control, right? Well, I imagine it would be hard to control, like in some
Yes,
ways. Right.
very much so.
Right. Yeah. So the definition itself has a lot of components to it. And it sounds like we're trying to define them still. Or not we, I'm not. People who are smarter than me are trying to define them. And it gets messy. Okay. That is very good. You had mentioned when we were doing a little prep for this episode, you mentioned, so we talked about isomers, defining what those are. Synthetic isomers came up. What are those? Because those are also at play, yes? And maybe a question for researchers.
Yeah, and synthetic is challenging because synthetic sort of implies that it didn't come from the plant at all,
Right.
and that it's made
In a lab or
out
something.
of other things.
Yeah.
Yes, but actually, some of these isomers may be naturally occurring, and they just may not be at the concentrations. Maybe in the sort of raw plant material, they wouldn't have those concentrations. But once we get into all of these different kinds of products that are being made now,
Yeah.
perhaps they've been concentrated, or they may have been, again, not necessarily synthesized, but maybe a derivative of, like maybe they've been converted from a naturally occurring cannabinoid. So we've struggled with this in our community of like, how do we refer to these things? And at this point, we're kind of saying novel non-delta 9 THC cannabinoids, and just kind of because they're popping up. I mean, you're probably familiar with delta 8. I mentioned that's come up a lot.
Yeah. Yeah.
By the way, the delta 9, just so you understand what that is a little bit, there's a ring of carbons in THC, and the delta 9 is a double bond in that ring that goes starting at the 9 carbon. So delta 8 carbon, like delta 8 THC is just you move that double bond one spot around in that ring structure, and delta 10 you move it the other direction.
So is there a difference between all three of those other than the chemical structure? Like,
Well, that's another great question, and
okay.
maybe we'll probably talk about some of that in our other episode, because some of that gets
That
into,
gets into toxicology a little
right,
bit.
like, are there different effects, and what does that mean from the legal point of view, from the drug chemist point of view? Okay, well, is it not delta 9? Is it a derivative of delta 9? So where does that fall within the sort of the framework of, is this thing hemp or is it marijuana? And what do we do when it's not a plant at all? It's something that came from a plant, and now we're trying to backtrack and say, did this come from a hemp plant or a marijuana plant? And how in the world would you ever know that?
Right. Oh my gosh. Definitions, what fun. So that, like, at this point, I'm thinking there must just be so much research being done just to try and figure out what all this means. Is that true? Like, is NIJ supporting research kind of in these areas, or is there other stuff in the drug chemistry world that we are trying to figure out right now?
Yeah, so there's a lot that we're trying to do to, NIJ, we're always trying to support, particularly our practitioners, and state and local practitioners are our main sort of customers, and they're the ones who were really kind of hit the hardest with this. So I think we've talked about before that the number one call for service, that the things that come into a crime lab, a third of them come to drug chemistry. I mean, it's just
Wow.
the most by a lot. Yeah. Drug chemistry and tox together is half of all calls for service. So it's a lot. And so you already had this huge, sort of amount of casework coming in. And then now you've made it more complicated because you have to make this distinction. And so there's been a lot of research to try and figure out how can we give, practitioners particularly tools to enable them to do that job efficiently and correctly and accurately. So one line of research that we've had is with Dr. Robbie Musa at SUNY Albany. And so she's been looking at what's called the DART, which is direct acquisition in real time.
Okay.
It's a clever
Yeah.
name. So it's a particular instrument. So a normal sort of drug chemistry run takes, let's say, 10 to 15 minutes, which doesn't sound that
To identify whatever's in a certain substance or compound or whatever it is.
to get your spectrum out the end, and that'll tell you what's there and so forth. And by the way, when we're talking about the hemp situation, then it can be a little more complicated because, of course, we've got to be able to tell the difference between the THC and the CBD, for example, which, remember I said, they've got the same mass and the same structure. So you got to be able to separate them or do something else. So, 10 to 15 minutes doesn't sound that long. But when you think about the volume of casework, that can be a lot, right? So DART it literally takes seconds. It's, dip a glass tube kind of into a solution or sort of rub your gummy against it or whatever. And you just put it directly into kind of the inlet or the stream of this instrument, and a spectrum comes out. I mean, literally within seconds.
Wow.
So it's a little more complicated because of the THC CBD situation, but you can very quickly, first of all, see is there a cannabinoid, is there a THC or a CBD present? Very, very quickly. And then it's relatively straightforward. She's done a lot of work with some derivatizing agents. There's that derivatives word again. So we mean a little bit of a different thing. So we kind of will cause it to react with another chemical. And because of those slightly different structures, the way that they're built, the new compound will sort of add on to it, and it'll add on kind of in two places to one and one to the other. So now they have different masses, and now we're able to differentiate them by mass. And so it's pretty straightforward to derivatize it.
So it kind of tags them, so to speak, and like makes it easier to just keep track of everything afterwards.
Yes,
Okay. That's really
exactly.
cool.
Yeah. And you've got different, right. Right. And so then now you've changed the masses. So now they don't have the same mass. Now they don't have the same structure because one's going to have sort of two tags on it and one's going to have one tag on it, let's say. So once you're able to do that, then you can very quickly separate those. And so she's had really good luck with that quantification, calibrating that, and really being able to show some quantitative results, which of course we know is what we're all about now since we have hemp and marijuana. And she's been looking particularly at some of not the plant, but some of these other products. And so she's looked at a whole array of gummies and chocolates and I want to say beverages and a lot of these cosmetic type, balms and lotions and things like that. And the issue with some of those is when we talk about some of the instruments that we traditionally use for chemistry in general, you have to be really careful of what you put on your instrument. And so the more So it'll still work. So you don't gunk it up, right? So you literally don't put a bunch of like lotion into your $500,000 instrument. Like that's not great. That's not ideal. So if you're gonna, so then if you have to do more steps to extract it, there's that word again. But if you have to clean it up a lot, then again, that's adding to the time it takes to do data analysis.
And with so much demand, even that little amount of time adds up.
Another line of research that we've had is with Brent Wilson at NIST, the one in Gaithersburg, and he was looking at the plants and the differentiation of the plants. And then now he's also moved into some of those what he's calling finished products. So again, some of those edibles and oil, a lot of the oils, the vape oil is a big thing. And so, so the vape stuff, and a lot of these oily type things.
CBD oil too? Because some of those are, I've heard, right? Like some of those are like CBD, but you might have some other stuff in them and it can get tricky, right?
Yeah, that's where they could go sort of full spectrum cannabinoids, whatever. And some of them, so Brent and I co-wrote an article. It was in Police Chief Magazine, I think October. And talking about some of the results. And so just out of those first results out of the plants, before we even get into the finished products, he'd bought over 50, I think, different plant samples marketed as hemp. And when he actually did the analysis, he found that the vast majority of them were not legally hemp.
Oh, wow.
They're legally marijuana. Now,
that throws a wrench in things.
That's if they're more than a point. Yes, it does, right? But the problem is, it's not more than 0.3%. So some of these were like 0.35%, 0.4%. Okay, so they're really tiny amounts. So the implication, who can say? But the implication is this is legitimate farmers legitimately trying to grow hemp. They're not trying to grow illicit marijuana and get you high because, quite frankly, you'd have to smoke a joint the size of a telephone pole to get much off of that 0.35%, right? So it's just a really hard line and it's a really low line. Yeah. So I don't have better answers, but it's sort of fascinating where that 0.3% came from too. It seems to have come from like one mention hypothetically in an article from like the 1950s and kind of got picked up and run with because we don't know because we've done things sort of qualitatively for a long time.
Right. So now there's a switch and so we're kind of filling in that gap now.
Exactly.
Yeah, that makes sense. Were there other projects that I can't remember. Were there other projects that we're working on that you wanted to highlight?
So Dr. Moose is going to be starting a new project, hopefully in January, and under our last round of funding. That's really exciting. Looking at some heavy metal complexes. So going away a little bit from her DART work to do some more rapid kind of field level discrimination of hemp versus marijuana. And that's, pretty critical too, because there's, if you can presumptively say, this is hemp, this is someone's got a bunch of hemp, whatever, then you don't go down a route of, potentially having someone possibly facing a charge that then later would be dropped after it goes through the full analysis at the lab, et cetera. If you can do kind of presumptively put things into bins to start with, that is better for everybody.
Okay, so those NIJ researchers, like they're doing fantastic work. I guess, how does that end up back in the field? Or like, what's the trajectory to get that, I guess, like back in the field, helping people on the ground, like do what they do?
Right. So I'll start with Dr. Musa and some of the DART work that she's done. And so, like I said, it's a much faster process. So the hope would be that labs that have a DART instrument could find a way to implement that into their casework processes, and that would allow them to screen, these potentially, really large quantities of marijuana casework that are coming in much faster, and that would help them to kind of stay on top of that. Now, I will say that the downside sort of there is the DART is pretty expensive. and not so it's not everywhere, right? So not every lab has a DART, and not all of them have been successful in implementing it into casework. So we hope that will allow the ones that do have it to implement it. Maybe some others will be able to get it. But the work that Dr. Wilson's doing at NIST that we've funded has a really, National Institute of Standards and Technology.
Okay, awesome.
Yes.
Awesome.
Our federal partners over there with standards and technology. And so you can tell in the name, right? Like standards. So they're very into process, which is great. And so that award and that research has had a very strong tech transfer element to it. So they have videos. I think they have a couple that are up right now where they're literally walking you through some of the steps of the procedures. For the plant, they're working on that for the finished products. They've got some that walk through the math that's involved, because remember we talked about that whole dry weight thing and percentages and so forth. There's complications because THC acid, THCA, converts to THC. So that gets into, is that part of this delta 9 THC concentration, and how do you calculate that? And so they are very focused on not only using real world samples to validate and to test, but also to have those procedures and workflows and videos available so that can get out to as many labs as possible. And they're using technologies that are in a lot more crime. So they're using GC mass spec, which is an instrument that's going to be really, really common in just about every drug chemistry section.
That makes sense. That's awesome. That's fascinating research. We'll have to come back and get some updates on these in the future.
Yeah, absolutely.
Thank you so much for the first half of our conversation, talking us through the drug chemistry and marijuana and all that. As always, I learned a lot. So thank you.
Fantastic. Thanks, Josh.
Thanks, listeners, for tuning in. Please follow us. If you like what you heard, follow us on Spotify, Apple, or wherever you get your podcasts, and stay tuned for part 2, where we dive into the toxicology.
To learn more about today's topic or about NIJ, visit the links in the episode description and join us for new episodes every month. Opinions or points of view expressed in this episode represent a consensus of the authors and do not necessarily represent the official position or policies of the U.S. Department of Justice. Any products and manufacturers discussed in this episode are presented for informational purposes only and do not constitute product approval or endorsement by the U.S. Department of Justice.